Okay, section 3.2 from chapter 3, methods of calculus. We're going to look at the mean value of a function over the interval a to b. It's simply defined. You put y bar, and then you've got to find the integral of that function. So I've marked it, highlighted it with the black area, and then you divide it by the width of that integral. So really, of a width of the interval between, so the limit between which the integral is evaluated. So technically, if you look at the picture, what you're doing, you're finding what height would this rectangle reach if you were to obtain the same area as the area under the curve. Okay, so this is what the mean value of the function is defined as. So it's really nice and easy topic. We're going to find example 4, the mean value of this function, so that as soon as they say find the mean value on the interval 2 from 2 to 6, you are going to call it f of x bar, and then you're going to divide by the width of the integral, so 6 minus 2, and then integrate it between the limits 2 and 6. So it's going to be 4, I'll bring it to the top, 2 plus 3x to the power of minus a half dx. So this one you can either use substitution, or if you remember from the rules of integrating such expressions, you can just use quick reverse chain rule. So you are going to add 1 to the power, divide by that power. So you're going to divide it by a half, and you are also going to divide by 3, and then you're going to write 2 plus 3x to the power of a half. The limits are 2 and 6. So tidy this up. You can bring 4 times divided by a half, so 8 over 3. It's going to be 8 over 3 times a quarter. If you want to bring it in front, that's fine. And we're going to put the limit of 6 into this, so 2 add 3 times 6 to the power of a half, so square rooted, and then 2 plus 3 times 2 to the power of a half, so 2/3. Okay, so this is going to be 18 add 2, so square root of 20, minus 6 add 2, so square root of 8. So this is 2 root 2, and this is 2 root 5. There you go. So let's just bring that 2 out. You will have 4/3 root 5 minus root 2. Okay, so that's example 4. Let's go at example 5. This time we've got to find the limit of, the mean value of this function on the interval between ln2 and ln6. So f bar is going to be, first of all, we've got to put ln6 minus ln2, 1 over in front of the integral with the limits ln2, ln6 of 4 over 1 plus e to the power of x dx. Okay, so first of all we need to have a go at integrating this function, so I'll do it on here. I think the best way of doing it is just replacing this e to the power of x, or you could even replace 1 plus e to the power of x in the denominator if you wish. So use substitution. So either replace the whole denominator or just e to the power of x to the whole denominator. So if you differentiate that, you're going to get e to the power of x dx. So du is going to be, sorry, e to the power of x dx. Okay, we haven't got that, so we're going to replace dx with du over e to the power of x. Okay, what I like to do here is just quickly rearrange this and substitute, replace it with u, so u minus 1 will be substituted instead of e to the power of x. So dx is going to be du over u minus 1. Okay, I'm ready to do substituting. So I is going to be equal to the integral of 4 over u, and then you've got du over u minus 1. So we've got to integrate this fraction. So now we have to use partial fractions. So split it into partial fractions. So lots of methods here. A over u plus b over u minus 1. So let u be equal to 0 first of all. Let me just rewrite the numerator so you know what I'm substituting it into. If u is equal to 0, we are going to have 4 is equal to a times minus 1, giving me a is equal to minus 4. And then we're going to let u be equal to 1. That will go away, and you're going to have 4 is equal to b times 1, so b is 4. So coming back to this, our integral becomes a is minus 4, so this is minus 4 over u, and then plus 4 over u minus 1, and perfect. So you've got minus ln u plus, and even 4, we've got the 4 plus 4 ln u minus 1. Let's go back to our x's. So 1 plus ex minus 4 ln of 1 plus ex plus 4 ln of ex, which is ln x. Okay, I'm going to write it down over here. Let's just combine these two. ln 6 minus ln 2 is going to be ln 6 divided by 2, so it's ln 3. Okay, so I had to rewrite it on a separate piece of paper, I didn't have enough room there. So this becomes, you've got 1 over ln 3. We're going to substitute ln 6, so 4 ln 6 minus 4 ln, and you've got 1 plus e to the power of ln 6 minus, let's substitute ln 2, so we've got 4 ln 2 minus 4 ln 1 plus e to the power of ln 2. Okay, so this one here becomes 1 plus 6, 7. This here becomes 1 plus 2, so it's 3. Okay, so it's 1 over ln 3. Then you've got 4 ln 6 minus 4 ln 7 minus 4 ln 2 minus plus 4 ln 3 let's combine them. So you've got ln 6 and ln 3. So you've got 1 over ln 3, and then you've got 4 ln, you'll have 6 times 3, and then 7 times 2 on the bottom. That cancels. So it's 4 ln of 9 over 7 over ln 3. Now let's have a look whether that's right, because the question was actually to show that the mean was indeed this. So it's perfect. Good. Okay, now let's have a look at part B. In part B, we are going to just read what it says. We've got to find the using the answer to part A. We're going to find the mean value over the interval ln2, ln6, so that's not changed, but we are dealing with f of x plus 4. So really what we're going to do, think about it, is shifting the function up. So I think the mean will be 4 more than the previous one, but we can actually have a go at doing it from scratch, because they have not asked us to do it geometrically. So over here we've got to find the mean, so it's exactly the same as before. So this one will go to ln6 minus ln2, which is ln3, and then we've got to do the limits the same, and the function is 4 over 1 plus e to the power of x plus 4 dx. I will do the rest on a separate piece of paper. So this is part B continued. So we've got 1 over ln 3, and then over here the first part you've already found the value of that between the limits ln 2 and ln 6. We have already found it. It was this 4 ln 9 over 7 ln 3. So it's 4 ln 9 over 7 over ln 3, and then we've got to add to that. I'll just keep it separately. Oh, sorry. Let me just make it a bit more clear. Right, let's split it. You've got so imagine going through from that and then splitting this into 2 integrals. So it's 1 over ln 3 integral between ln 2 and ln 6 of 4 over 1 plus e to the power of x plus 1 over ln 3 integral of 4 dx. So that's what I'm going to do. This is that part over here that I've scribbled over, which wasn't necessary now, but let's just move on. So we are going to do, actually turn it over so it's a bit cleaner. So you have got in part B, the first part was 4 ln 9 over 7 over ln 2, ln 3. That was this integral over here. And then the second one is going to be 1 over ln 3, and we're going to integrate 4, which goes to 4x, and it's between ln 2 and ln 6. So this is f bar plus 4, the mean value. So it's 4 ln 9 over 7 over ln 3 plus 1 over ln 3. We're going to put 4 ln 6 minus 4 ln 2. This here is 4 ln of 6 over 2, which is 4 ln 3. So overall this part is going to be 4 ln 3 over ln 3. That cancels, and you're left with plus 4. And this is what I said to you. If you imagine adding 4 to a function, f of x, it shifts the function 4 units up. Therefore, the value of the mean value will also be shifted 4 units up. Okay, so let's just, hopefully I'll have enough, maybe not enough room, but let's just read what the question asks you. It says to use geometric considerations to write down the mean value of minus f of x bar over the interval ln2, ln6. So if we have the answer of f bar being 4 ln 9/7 over ln3, so imagine maybe this is the graph, something like this, I don't know, and that is, and you found the mean value of that graph to be, you know, maybe somewhere here, and so that gave you f bar. Now if you stick a minus in front of that function, you are considering the function that's below it, below the x-axis, so that will be minus as well. So the mean of the opposite function in value will be opposite, because anything under the axis will be negative. So you could say the f of x is reflected in the x-axis, thus the mean is going to be negative. Okay, so you're ready now to go on onto exercise 3b. Just before you quickly before you go, these are quite common results to do with the mean value of the function. Okay, so the mean value of f plus k is going to be equal to f plus k. The mean value of, if you multiply the function by k, that will be the same as k lots of the mean value. And if you reflect the function, the mean value is going to be minus that. So the mean value of the opposite function is minus whatever the mean value was of the original function. If you reflect it in the y-axis, that does not change. So if you do this, it's not stated in the book, but I will just add it, because you just think about geometrically. If you flip it on the other side, it stays positive. If it was positive, it's going to be the same, stays negative if it was negative. Okay, so that leads to exercise 3b. Enjoy.